Hey, iqkid here to talk about limiting reactants. So to start, let's define what a limiting reactant is. So it is the reactant that runs out first in a chemical reaction and thus limits the amount of products that can form. So to better understand limiting reactants, let's look at a non-chemistry related example. So in this example, we're going to use bread and sandwiches. Okay, so your most favorite sandwich at Willie's Deli has 3 slices of bread, 8 slices of meat, 4 slices of pepper jack cheese, and 1 serving size of the specialty sauce for 1 complete sandwich. How many complete sandwiches can be made with the following amounts? 30 slices of bread, 40 slices of meat, 32 slices of cheese, and 7 servings of sauce. Okay, so step 1 is to write the reaction, quote unquote reaction, the chemical equation, I guess, the formula, and balance it. So let's do 3, so B plus, so B for bread, so the 3 is the number of bread we need, so plus M plus C plus S, so M is meat, C is cheese, and S is sauce. And that goes to 1D for deli or sandwich. Okay, so we need 3 bread. To balance this, we need 3 bread, 8 meat, 4 cheese, and 1 sauce to get 1 sandwich. Okay, so then step 2 is to use these ratios to get the number of sandwiches we can make. So we have 30 bread divided by the number of bread per sandwich, so that's 10 sandwiches worth of bread, sandwiches of bread. So then we also have 40 meat divided by 8 slices per sandwich, so that's 5 sandwiches worth of meat. So then we also have 32 cheese divided by 4 slices of cheese per sandwich, so that's 8 sandwiches worth of cheese. And we have 7 servings of sauce, so that's 7 servings per 1 serving per sandwich, so that's 7 sandwiches worth of sauce. Okay, so then step 3 is to compare these values to try and find the limiting reactant. So we have 10 D of B, so sandwiches worth of bread, 5 sandwiches worth of meat, 8 sandwiches worth of cheese, and 7 sandwiches worth of sauce. So if you look at these, this right here is your smallest number, which means that it is the limiting reactant. So you can get 5 complete sandwiches is your final answer with meat as the limiting reactant. Okay, so this is your final answer. Okay, so now let's look at an actual example with chemistry. Okay, so in this example, we're going to look at this. So 25.0 kilograms of N2 gas and 5.00 kilograms of H2 gas are mixed and reacted to form NH3 gas. So part A is what is the limiting reactant, and part B, what mass of NH3 gas is produced. So step 1 for part A is to write and balance the reaction. So to do that, we're going to have N2 gas plus H2 gas goes to NH3 gas. So to balance this, let's look at the number of nitrogen atoms we have on the reactants and product side. So to balance that, we need to put a 2 here to have 2 nitrogen. So now we have 6 hydrogen, so we need to put a 3 right here, and that actually balances, so this one is just a 1. So then step 2 is to convert to moles. So we're going to take the 25.0 kilograms of N2 and multiply it by 1,000 grams per 1 kilogram, and multiply that by 1 mole of N2 over 28.02 grams of N2. So this is to get it to grams, so that way that cancels and that cancels. That cancels with that, and then the grams cancels with that to leave you with just moles. So that would equal 892.2198 moles of N2. Okay, and then for hydrogen, let's do 5.00 kilograms of H2 times 1 kg under 1,000 grams times 1 mole of H2 over 2.016 grams of H2, and that leaves you with 2,480.1587 moles of H2. Okay, so then step 3 is to use the mole to mole ratio that we get from the balanced equation from earlier, so 1 to 3 or 1 to 2 or 3 to 2, etc. And we're going to use that to find the limiting reactant. So let's take the ratio of nitrogen and hydrogen in the following form. So 892.2198 moles of N2 times 3 moles of H2 per 1 mole of N2. So that's going to cancel with that and leave us with that, with the moles of H2. So the reason why we do this is because it tells us with this amount we need the top amount, the value, a certain amount of the numerator to get to completely equal and use up all reactants. So that's going to equal 2,676.6594 moles of H2. Okay, and now let's go ahead and compare this to the original value. So let's bring this down. So 2,676.6594 moles of H2 in comparison with 2,480.1587 moles of H2. So obviously 2,676 is bigger than 2,480, which means that H2 is the limiting reactant, because this is how much we have right here. This is how much we have. To use up all of this, we would need that much. So because we only have this amount, therefore H2 is the limiting reactant. Okay, and then just to show you how to do the other one, I'm going to go ahead and convert H2. So, and to see how much N2 we would need. So 2,480.1587 moles of H2 times 3 moles of H2 under 1 mole of N2 is equal to 826.7196 moles of N2. So then if you were to compare that, that'd be 826.7196 moles of N2 is less than 892.2198 moles of N2. So this is what we have again. So since we have more than what we need to use up all of the H2, we have an excess. So excess, so it is not the limiting reactant. Okay, so now let's do part B. So in part B, step 1 is to use the mole-to-mole ratio. So just to remind you what we're supposed to do in part B, we're supposed to find what mass of NH3 the product is produced. Okay, so using the mole-to-mole ratio, we use the limiting reactant, how much we have of that, so 2,480.1587 moles of H2, and use the mole-to-mole ratio, which we get from our balanced reaction. So that would be, see if I can, here it is. That would be 3:2. So that would be 2 moles of NH3 per 3 moles of H2, and that's going to equal 1,653.4391 moles of NH3. Okay, so then it asked for the mass, so we have to convert from moles to grams. So 1653.4391 moles of NH3 times the times 1 mole of NH3 under the molar mass of NH3, which is 17.034 grams of NH3. And that gives us 28,164.68 grams of NH3. Okay, and we have to put this in the correct number of significant figures. So this is actually, so I'm going to put in scientific notation just because it's easier. So I'm going to put it as 2.82, since we can only have 3 significant figures, because in the original values have 3 significant figures, 1, 2, 3, 1, 2, 3, so we can only have 3 here. So we round that, get 2.82 times 10 to the 4th grams of NH3, and that's your final answer for part B. Alright, well, I hope this helped. Thanks for watching. If you have a question or something is unclear in this video, feel free to send me an email, which will be in the description. And if you have a request for the next video that I make, you can also contact me through my email for that. And yeah, so have a wonderful day, and IQ Kid signing off.